Hey, P99Conf. We would love to do these presentations on site, seeing people face to face. Unfortunately, these days we all know we have to deliver them virtually, which doesn't mean that we do any worse job than when we do it on site. So today I'm going to talk about using SLOs for continuous performance optimizations for your Kubernetes workloads. I know that's a mouthful of a title. My name is Andreas Grabner. I'm a DevOps activist at Dynatrace. I'm also a DevRel and a core contributor to the open source project Keptn. The conference staff has asked me to, show you a little bit more about myself, who I am. I already told you what I do in my regular life, but some things maybe that you don't know is that I've actually been doing performance testing for more than 20 years. Recently focused on observability more so because my work at Dynatrace. I also host a podcast called Pure Performance. So performance is truly in my life. If you want to ever listen to some of our episodes, check it out. And away from work, you find me salsa dancing, assuming that the current COVID pandemic allows salsa clubs to be open. All right, but let's get into the topic. So we talk about SLO-based performance optimization. And as I said, I've been doing performance testing for about 20 years, so I've always try to optimize performance. And in order to do this, I found a lot of patterns that I'm always watching out for. And this is why I want to start with performance patterns, because I think we all need to understand how our software and systems behave, which patterns to look out for, and then taking this data to then start optimizing. I really love distributed traces. Distributed traces is nothing new, but it just recently got really hyped with all the work that has especially been done in the open source world around open telemetry. What you see here is a so-called distributed trace visualization of one of the customers and users that I'm working with and I've worked with in the last couple of years. And as I build out here my slide, you can see a distributed trace typically starts at the front end where requests come into your system and then go through different services, external, internal services, those that you host, those that may be hosted in your cloud vendor. What's very important is that you look at these distributed traces so you know your dependencies and you know where time is spent. You know which service is calling which other service, because as you change things in your architecture, you know which potential impact your changes have and also which metrics to watch out for. Okay, so distributed traces, if you have not kind of looked into this type of data, please do so. There's a great source of information, insights about your architecture, about your performance problems, about your architectural challenges. Now, next thing, again, another distributed trace, an individual one that was actually sent to me by one of my friends who developed years ago an e-commerce solution, very small startup, and then it grew and grew. And he sent me a distributed trace that I then analyzed, and I found the #1 performance pattern that I see out there in the world. It's the so-called N+1 Query Issue, which means this is a distributed trace of a search action on his e-commerce system. So somebody was searching for products in the product catalog. The way he implemented it is very classical. Execute a select statement that is pulling back the number of product categories and then going off and iterating through the number of product categories and querying the individual products per each category, which is a very bad thing to do. It's the classical N+1 query problem. So give me the number of items or IDs or groups and then go back and execute the same query multiple times to fetch the, in this case, product details. In his case, as you can see, he ended up with 26,000 database calls just to show a particular search result of a product query. Now, the problem with this is also a data-driven problem. The more product categories, the more products in the database, the more SQL queries are executed, the longer it takes, the more stress it is on the database, on memory of your system. And you can see here, there's clearly some metrics we can look at, like the number of database calls being executed on a particular transaction. I also see the same pattern, the N+1, not only with the database, but especially with microservices environments from microservice to microservice. So here's another view of such a distributed trace where one service calls another and then iteratively and recursively kind of goes off in a chain. And this is a bad picture from my perspective, there's something wrong with the architecture. But again, we can also use metrics to identify it, like how many services are involved. Is the same service involved multiple times in an end-to-end distributed trace? So we can extract this through metrics and not only identify the patterns visually. Now, there's many more patterns. This talk is not about patterns, but I think it's important for you to understand these patterns. If you want to learn more, I've talked about this for the last 10 to 15 years. The 3 recent presentations I did are listed on the bottom here. You can see the links. You can find them on YouTube just by searching for, let's say, this, the San Francisco Java Meetup, Confitura 2019, or the Performance Summit earlier this year, where I talk about more of these patterns, how to identify them, and most importantly, how to look at these metrics. Okay, now I talked about patterns and I talked about metrics. The talk is about SLO-based optimization of your Kubernetes workloads with an open source project that I'm driving, that I'm contributor to. I'm not the only one, obviously, but I'm now here to tell you a little bit more about Keptn, because Keptn allows you to automate your performance-based optimization based on SLOs, service level objectives. And if you know SLOs, which I'm sure most of you do, SLOs are based on metrics, like what I've just shown you earlier, against certain thresholds. If you know your patterns, you know your metrics, and you know what you want to watch out for, which patterns and which thresholds, then we can use Keptn to automate the analysis of your patterns. And with this, find performance problems early and hopefully avoid them. So now, Keptn from 10,000 feet. If this is the first time you hear about Keptn, it's a CNCF project, a Cloud Native Computing Foundation project. It's declarative and an event-driven. What does this really mean? If you install Keptn, you install it on Kubernetes, you get a control plane that is managing and later on automating your so-called automation sequences. So Keptn can do many different things, and it can automate sequences that you like to automate. The nice thing is, if you want Keptn to automate something, you declare this in a so-called shipyard file, where you say, Keptn, here are my processes that I want you to orchestrate for me, whether it's around delivery, around auto remediation, around testing, or just evaluating your SLOs. So you declare it, one team, let's say the site reliability engineers, define the processes that should be automated. What Keptn makes so unique, I think, is the separation of concerns, because there's no tooling that you specify in the process. So the site reliability engineers specify the process, where maybe your DevOps team or your tooling team defines which tools should then actually be part of the automation that Keptn orchestrates for you. It's specified in a so-called uniform file. Everything is connected through events, so it's loosely coupled as well. The beneficiary of all of this is, for instance, your developers, your performance engineers, your architects. Because as a developer, if I'm using Keptn for end-to-end orchestration of my delivery process, I can say, here is a new artifact. Now please, Keptn, go off and orchestrate the workflow that my site reliability engineer has specified. Do the deployment, do the testing, do the evaluation, make sure monitoring is correctly configured, notify the right people. And Keptn through events is then at the right moment in time, triggering the right tools through events to then do a particular job. A key point here is actually in the bottom, in the middle. You see the little traffic light. That's the evaluation, because what Keptn does all the time, it evaluates your system against SLOs in every step along the way. And this is what I want to really focus on, because the talk today is not necessarily about the whole capability of Keptn, but really about this very core capability of analyzing and pulling out metrics from your observability platform and comparing them against thresholds. So now what Keptn does extremely well in this case is, instead of, if you're a performance engineer like I've been doing for the last 20 years, if you build your dashboards and you are looking at your metrics, at your traces, what we saw earlier, then of course you can visually look at the dashboards every time you have a new build available and then say, hey, I know this is bad because this goes beyond the threshold and these two metrics are kind of interrelated, and therefore if one goes up, I know the other one also has to go up. So while this is possible, it is error prone and it takes long, and also it's just you that can do it if you are the expert. And therefore Keptn really automates this particular process by allowing you to specify which metrics, which SLOs to validate fully automatically whenever you ask Keptn to do so. This is faster, this is not error prone, everything, it always works consistently, and it can now all of a sudden be used by everyone in your organization and not just for those experts that know how to look at these dashboards. All right, some examples, Christian, senior DevOps engineer at ERT, he brought in the automated SLO validation into his GitLab pipeline. So instead of manually doing this and therefore slowing down the pipeline by manually looking at results, he is just triggering Keptn. Keptn is then pulling out the metrics from his observability platforms, in this case Dynatrace, gives back a score, and therefore the pipeline continues or stops depending on that result, which is now fully automatically evaluated. And most of these metrics are obviously performance related. This is why with this you can really optimize your performance, because you give proactive feedback to every developer every time they commit a change. The pipeline runs, whatever pipeline you have, and then your SLOs will automatically be validated. Let me have a closer look at SLO validations if you want to use it. If you're completely new to SLOs, do me a favor and just check out a little bit of the material that Google has kind of put out there. But essentially, you need to define so-called SLIs, service level indicators. They're really just metrics from, let's say, from your Prometheus, from your Dynatrace, or any other tool, from your testing tool. I just have 5 examples here. Then you need to specify SLOs. SLOs are your objectives. So what do you expect the metric to be in order for you to either consider it completely green, like everything is good, or maybe in a warning range? So with Keptn, we also allow you to exactly say, this is pass and this is warning, where you can either specify absolute values, like what you see here with the 100 milliseconds, or you can also do relative values, where you look at the test step login number of service calls, where it says plus 0%. This means Keptn will then make sure that this metric does not increase at all to the previous build. So Keptn can also do regression detection by looking at baseline data, and therefore violates or penalizes you in case the metric goes through the roof. So you also specify an overall goal, because we always calculate the total score from every SLI. And then we normalize it between 0 and 100. So example, build 1 comes along, Keptn pulls the data out of your monitoring tool, everything is green, perfect, you get 100%. Build number 2 comes along, developer makes a change, introduces a regression on the number of backend service calls. So it increases from 1 to 2, which is violating our rule. This is a regression. Immediate feedback back to the developer. Not a good thing. Also, response time is higher. Performance problem. Build number 3, developer fixes the thing right away. Performance is great again. Number of service calls are back to 1, but all of a sudden they introduced a security vulnerability, because this is not only there for just performance optimizations or performance metrics or architectural metrics, but also you can pull in your security scans. Did you find a vulnerability? And in this case, you're getting penalized. It's not enough. But the good news is the developer gets immediate feedback, therefore fixing the problem right away, running another pipeline, and hopefully then everything is safe and sound and all good. All right, so this is a quick overview of how SLIs and SLOs work. In Keptn, the way this works, you could trigger, as I said, a so-called automation sequence, and the basic automation sequence includes an evaluation. So that means if you trigger an evaluation, we have a service in Keptn called the Lighthouse service. The Lighthouse service is then reaching out to your SLO definition, which is stored and maintained in a Git repository. So you can define in Git as configuration what your SLOs should be. That's your criteria. Now, in order to pull that data, and this is again separation of concerns between the definition of your SLOs and where the data comes from, you can have multiple data sources. That means we have so-called SLI providers that, again, through YAML, you can configure, for instance, how you get this particular metric out from Prometheus by specifying PromQL, or if it's Dynatrace, the Dynatrace query language. Okay, so the point here is the Lighthouse service coordinates by talking to these monitoring tools, giving them the definition that are defined in the Git repository. They pull back the data through the APIs, give it back to the Lighthouse service, and then the Lighthouse service is calculating the overall score. And I think this is, making life much easier. Everything is declarative. Everything is also tool independent. You can add any type of a monitoring tool that you want here, or any type of data source pretty much. So to kind of sum this up again, what is really important for you if you want to try this, pick your SLOs. You can also pick your testing or your end-to-end automation. I think this is also very important. All of this only works if you really have tests that you can execute on a regular basis, unless you do this and apply this into production and maybe run production evaluations every hour, every minute. But if you want to do this in testing and you don't yet have a way to orchestrate tests, you can also use Keptn for it, because remember, Keptn can orchestrate automation sequences. The minimum sequence is just the evaluation, but you can add a test to it. So Keptn can trigger your tests. Keptn can even deploy if you want to. Or you have already all of this in place. Maybe your Jenkins pipeline, your GitLab pipeline already does deploy test. Then just do it like Christian from the example earlier, and just use Keptn for the quality gate evaluation, for the SLO evaluation. Now, Keptn in the real world, what I showed you so far are examples. There are real world examples out there. For instance, I am from Austria. The Austrian software organization that is building most of the online banking software for most Austrian banks is using Keptn to automatically validate every release of their e-banking software. So every time a new build comes through, in their case they're using Jenkins, then they're running Selenium tests, then Keptn comes in and they use it for automated SLO validation, immediately giving them feedback if something has changed in a bad or in a good way. So also the Medium link on the bottom, there's a blog post about it. Another one, Mike, he is a performance architect at NAIC. He's using LoadRunner for his performance tests. Up until he found Keptn, he has built dashboards and manually sat there. In the video where he walks us through, he says Keptn saves him about 30 to 60 minutes every day when he's analyzing his load testing results, because he's pulling back the information from his load test and let Keptn then automate the analysis. We also have other environments or other stories from other companies here from Vitality, where they are using the SLO validation to validate the stability of an environment when they're deploying their software for multiple tenants with different feature flags turned on. So every system behaves slightly different, even though the basic code behind the scenes is the same, but if they have a multi-tenancy system, and they're using Keptn to validate any change for individual tenants based on their feature flags. Last, what I want to show here is we've also been recognized by leaders in the performance space, in the site reliability engineering space. Tarash, he's a performance engineer at Facebook, and he posted this nice comment on LinkedIn where he says Keptn feels like a reference implementation of Google's site reliability engineering and the site reliability workbook. So that's a great testimonial for somebody that has been working in performance, in high performance for a long, long time. Now, let's wrap it up so that we make sure we also have some time for questions. What I would like you to do is, if you don't know your patterns yet, if you don't know your architecture, please look at the data that you have. If you don't have distributed traces yet, then try to get tools. There's free tools, open source tools, and also commercial tools that can do it. So understand your architecture, your distributed traces, and your patterns. Then monitor all these metrics. It's not just about visual pattern detection, but it's about figuring out which metrics can tell you whether you have a certain pattern. Put them on a dashboard and then start analyzing what is good and what is not good. Then let Keptn automate the whole thing. Instead of you looking at the dashboards, you tell Keptn how to analyze these metrics by specifying the SLI and SLO definition. And then integrate this into your existing delivery and operations tools. Because Keptn, as I said, can do much more, but start with quality gates, but then you can also have Keptn to automate your tests, your deployment, also auto remediation in production in case you find problems in prod. Maybe you can even want to roll back to a previous release. If you want to learn more about Keptn, I've done several talks in my role as an advocate for Keptn. As I said, I'm a contributor as well. I did a CDCOM presentation recently and one for scaling continuous delivery, where I walk through more details of Keptn, how it works, use cases. So check it out. It's all out there. If you want to become a member of the Keptn community, we're always looking for people that are giving us feedback, that are extending Keptn. Go to keptn.sh. That's our website, or go to the GitHub repository, follow us on Twitter. But if you go to the website, you see on top additional links to resources, also tutorials. Or if you want to explore Keptn live, we also run a live, we host Keptn in a live instance where you can click around and see how it works. All right, with this, I want to say thank you so much. As I said, hopefully the next time this conference comes around, we'll all see each other in real life and not on a video channel. But with this, go out, understand your architecture, define your SLOs, and let Keptn do the heavy job by letting Keptn automate some of the stuff that you otherwise need to do manually. Thank you. Tschüss. Bye.